You are lying down right now, feeling the gentle weight of your body pressing into whatever surface holds you. This weight, this soft pressure you feel, is gravity's quiet touch. It has been with you since before you were born, constant as your heartbeat, faithful as your breath. Take a moment to notice it now. Feel how your shoulders sink slightly into their resting place. Notice the way your head creates its own small impression where it lies. Even your eyelids so light they barely seem to exist. Rest gently closed because gravity draws them down. This is gravity's first gift to you tonight, the gift of rest. Every atom in your body knows this ancient pull, from the calcium in your bones to the iron in your blood. Each particle feels the earth calling softly. Rest here with me, and you do. You rest. You let gravity hold you like a mother holds a sleeping child, with infinite patience and perfect gentleness. But gravity's embrace extends far beyond this moment, far beyond this room. Right now, as you lie here breathing slowly, gravity is performing miracles all around you. The same force that keeps you safely nestled in your resting place also holds the moon in its monthly dance around Earth. It keeps Earth circling the sun in an endless, peaceful orbit. It binds galaxies together across distances so vast, your mind can barely imagine them. Think about that for a moment. The very same force that makes your blanket drape comfortably over your body right now also guides stars in their courses through the cosmos. There is no difference between the gravity you feel and the gravity that shapes the universe. You are connected through this invisible embrace to everything that exists. Your body understands this connection even when your mind is too busy to notice. Every cell in your body has evolved in gravity's presence. Your bones have grown strong precisely because gravity has been pulling on them your entire life. Your heart has learned to pump blood upward against gravity's pull, growing stronger with each beat. Even your inner ear, that delicate instrument of balance, exists to help you navigate in a world where up and down have meaning, because gravity makes it so. As you breathe in slowly now and breathe out, you can feel gravity helping even with this simple act. When you exhale, gravity helps empty your lungs, drawing the air down and out. When your chest rises with each inhale, you're lifting against gravity's gentle resistance, and this tiny effort helps keep your breathing muscles toned and healthy. Scientists have measured gravity's pull with incredible precision. They know that here on Earth's surface, gravity accelerates objects downward at about 9.8 meters per second squared. But you don't need numbers to understand gravity. You understand it in the way water knows to flow downhill. You understand it in the way a dropped feather eventually finds its way to the ground. You understand it in the perfect arc of a tossed ball, rising and falling in a curve that artists have tried to capture for centuries. What's remarkable is that gravity never rests and never takes a break. Right now, as you lie here, you're actually falling. The earth beneath you is falling too. Together, you and the earth are falling around the sun. And the sun is falling around the center of our galaxy, and our galaxy is falling through space toward distant clusters of other galaxies. But this falling is so perfectly balanced by sideways motion that it becomes orbiting, dancing, wheeling through space in patterns of such beauty that they can bring tears to an astronomer's eyes. You're part of this cosmic dance right now, not metaphorically, but literally. The gravity you feel is your membership card to the universe's grand ballet. Every planet, every star, every grain of cosmic dust feels what you feel. They all know the pull you know. And here's something beautiful. Gravity's strength depends on mass and distance, following patterns as precise as music. The Earth pulls on you, yes, but you also pull on the Earth. Your gravity, tiny as it might be compared to a planet's, is real. You bend space around you. You create a little dimple in the fabric of reality just by existing. Every atom of your being announces to the universe, I am here and I matter. The moon feels your gravity. The sun feels it too, though the effect is almost impossibly small. But it's there. You are not just a passive recipient of gravity's pull. You are an active participant in the gravitational symphony of existence. As you rest here, feeling heavier and more relaxed with each breath, you might wonder how this invisible force does its work. How does the Earth reach out across empty space to hold the moon? How does the sun's gravity travel across 93 million miles of vacuum to keep Earth in its orbit? These are questions that puzzled the greatest minds in history, and tonight, as you drift towards sleep, we'll explore their beautiful answers. But for now, just feel it. Feel gravity's patient presence. Feel how it never hurries, never worries, never stops its gentle work. It has been here for billions of years before you arrived, and it will continue for billions more after the last star fades. Yet right now, in this moment, it attends to you with the same care it gives to galaxies. You are safe in gravity's embrace. You are held. You are exactly where you need to be. And as you feel this ancient force cradling you, you might notice your breathing has already grown slower, deeper, more peaceful. This is gravity's lullaby, sung not in sound, but in the language of weight and rest, of falling and being caught, of moving through space while feeling perfectly still. Soon we'll journey deeper into gravity's mysteries. But there's no hurry. Gravity has been waiting 13.8 billion years. It can wait a little longer while you settle even more comfortably into its embrace. As you lie here, held safely in gravity's embrace, let your mind drift to something you've experienced countless times. The warmth of sunlight on your skin. Even on a cloudy day, even through a window, you can feel it. That warmth has traveled 93 million miles through the vacuum of space to reach you. No air carries it. No substance bridges that vast gap. Yet somehow the sun's energy finds you. This is one of nature's quiet miracles. The ability of forces to act across empty space. Just as you can feel the sun's warmth without touching it, you feel Earth's gravity without any visible connection. These invisible reaches across distance have fascinated humans since we first began to wonder about the world. Think about a simple magnet. Perhaps you played with them as a child, feeling that mysterious push and pull as you brought them close together. You could feel the force through your hands, even though nothing visible connected the magnets. You might have tried to push matching poles together, feeling that strange, springy resistance. Or you let opposite poles snap together with that satisfying click. The magnets were talking to each other through empty space, just as you and the Earth communicate through gravity right now. Your body is having countless invisible conversations at this very moment. The iron in your blood responds ever so slightly to Earth's magnetic field. The water molecules in your cells dance to the faint pull of the moon. Every atom in your being feels the gravitational whisper of distant stars. You are never alone. You are always in dialogue with the universe through these invisible forces. But here's a question that might gently tug at your curiosity. When the sun's gravity pulls on Earth, how quickly does that pull travel? If the sun suddenly vanished, which it won't, you're perfectly safe. How long would Earth continue in its orbit before realizing its dance partner had disappeared? For centuries, people assumed gravity's effects were instantaneous. It seemed logical. When you set a cup on a table, it immediately knows to stop falling. When you drop a stone, it instantly begins its journey downward. There's no delay, no waiting. Gravity appears to work everywhere, all at once, like a cosmic conductor keeping perfect time. But light tells a different story. When you look at the sun, though please don't look directly at it, you're seeing it as it was about 8 minutes ago. That's how long sunlight takes to cross the 93 million miles between the sun and Earth. Light has a speed limit. It travels incredibly fast, 186,282 miles per second, but it still takes time to get from here to there. This speed of light is woven into the fabric of reality itself. It's not just about light. Radio waves travel at this speed. So do X-rays and all forms of electromagnetic radiation. Your cell phone conversations, the Wi-Fi signals carrying these very words if you're listening digitally, even the infrared warmth radiating from your body right now, all travel at light's cosmic speed limit. Scientists call it C for short, from the Latin word celeritas, meaning swiftness, and swift it is. In the time it takes you to blink, light can travel around Earth's equator 7.5 times. Yet even this tremendous speed has limits. Light from the nearest star beyond our sun takes over 4 years to reach us. Light from distant galaxies has been traveling for billions of years, carrying ancient stories across the cosmos to your eyes. As you breathe slowly in and out, consider this: in the time of one relaxed breath, light travels nearly 3 million miles. Yet gravity seems to care nothing for such journeys. The Earth responds to the sun's pull right now, not 8 minutes ago. The moon feels Earth's gravity instantly, not the 1.3 seconds light takes to make that journey. Or does it? This question gnawed at brilliant minds for generations. How could gravity be instantaneous when everything else in the universe respects the speed of light? It was like finding a secret passage that bypassed all the usual rules, a cosmic shortcut that made no sense. Your body might know the answer intuitively. After all, you've felt how waves travel through water, drop a stone in a still pond, and ripples spread outward at a particular speed. You can watch them go, these little messengers carrying news of the disturbance across the water's surface. Sound waves work the same way, traveling through air at about 767 miles per hour at sea level. That's why you see lightning before hearing thunder. The light arrives almost instantly, but sound takes its time. Could gravity travel in waves too? Could changes in gravitational fields ripple outward like waves on a pond, carrying their message at some finite speed? It was a beautiful idea, but for the longest time it remained just that, an idea. The universe keeps its secrets well, but it also leaves clues for those patient enough to look. And as you rest here, feeling the reliable pull of gravity, knowing that forces can reach across empty space, you're perfectly positioned to understand one of the cosmos's most elegant truths. Every force has its own way of bridging distance. Light leaps across space in straight lines or gentle curves. Magnetism reaches out with invisible fields. And gravity? Well, gravity has perhaps the most beautiful method of all. But to understand it, we need to think about space itself in an entirely new way. For now, just notice how comfortable it feels to know that forces can act without touching. Your lungs draw in air without reaching out to grab it. Your heart pulls blood upward without leaving your chest. You participate in action at a distance with every breath, every heartbeat, every moment of existence. The sun's warmth finds you across 93 million miles. Earth's gravity holds you across the few feet between you and the planet's center. The moon tugs gently at the water in your cells across 239,000 miles of space. You are surrounded by invisible connections, held in a web of forces that know exactly where you are and tend to you with infinite care. And somewhere in this network of invisible forces, gravity keeps its quiet secret about how fast it travels. Soon we'll uncover that secret together. But first, let's journey upward, beyond your resting place, beyond the clouds, to where gravity writes its most beautiful stories in the paths of falling stars. Above you right now, beyond the ceiling, beyond the clouds, beyond the blue of Earth's atmosphere, something magical is happening. The moon is falling. It has been falling toward Earth for billions of years, and it will continue falling for billions more, yet it never gets closer. This is gravity's most elegant dance, the art of falling without landing. You understand this dance in your bones. As a child, you might have spun around with your arms outstretched, feeling the way your body wanted to fly outward while your feet kept you anchored. Or perhaps you've swung a bucket of water in a circle, watching the water stay inside even when the bucket is upside down. These simple playground physics contain the same truth that keeps moons and planets in their courses. Right now, the International Space Station is falling around Earth. The astronauts inside feel weightless not because gravity has released them, but because they and their spacecraft are falling together, sideways fast enough that they miss the Earth with every moment. They fall around the curve of our world, eternal skydivers whose parachute is their own velocity. Feel your body resting where it is. You're not falling because the surface beneath you pushes back with exactly the force needed to balance gravity's pull. But imagine for a moment that this surface vanished. You would begin to fall immediately. No delay, no hesitation. Gravity would claim you in the very instant of release. This immediacy fascinated Isaac Newton. In his garden in Woolsthorpe, watching apples fall, though perhaps not directly on his head, as the story claims, he realized something profound. The same force that brings apples to Earth also keeps the moon in its path. The falling apple and the falling moon obey the same law. Newton imagined gravity as an invisible force that acts instantly across any distance. In his universe, every mass pulls on every other mass right now, this very moment, no matter how far apart they are. The sun's gravity grips Earth instantly across 93 million miles. Earth's gravity holds the moon instantly across the void. Every star tugs on every other star without delay. It's a comforting thought, isn't it? That gravity's embrace is always immediate, always present, like a parent who knows instantly when their child needs comfort. Gravity in Newton's view responds without hesitation. The universe is bound together by instantaneous connection, a cosmic web where every strand feels the vibration of every other strand the moment it happens. For over 2 centuries, this view of gravity explained nearly everything. It predicted the paths of planets with stunning accuracy. It explained the tides, those slow breaths of the ocean responding to the moon's pull. It even allowed astronomers to discover new planets by noticing tiny wobbles in the orbits of known worlds. But even as you rest here, held by gravity's patient force, tiny cracks were forming in Newton's beautiful picture. Mercury, the innermost planet, wasn't quite following the rules. Its orbit shifted slightly more than Newton's equations predicted. The difference was tiny, about 43 arcseconds per century, but it was real, and it was troubling. Imagine trying to meet a friend who's walking around a circular path. Newton's gravity says you can predict exactly where they'll be at any moment. But Mercury was like a friend who somehow got a little bit ahead of schedule. Not much, but enough to notice if you're paying attention. Where was this extra motion coming from? The stars themselves seemed to whisper that something deeper was at work. During solar eclipses, when the moon briefly blocks the sun's overwhelming light, stars near the sun's edge appear slightly out of position. It's as if the sun's gravity bends the path of starlight, something Newton's instant gravity couldn't quite explain. You can feel a hint of this mystery in your own experience. Have you ever been on a fast elevator? As it starts upward, you feel heavier. As it begins to stop, you feel lighter. For those brief moments, the elevator is changing your relationship with gravity. Einstein noticed something profound in this simple experience. Acceleration and gravity feel exactly the same. Close your eyes for a moment and imagine floating in a windowless room far from any planet or star. If the room suddenly started accelerating upward, you'd feel yourself pressed against the floor. It would feel exactly like gravity. There would be no experiment you could do inside that room to tell the difference between acceleration and being at rest in a gravitational field. This equivalence is more than a curiosity. It's a key that unlocks gravity's true nature. Because if acceleration and gravity are truly indistinguishable, then gravity might not be a force at all. It might be something far stranger and more beautiful. As you lie here, you're not just being pulled by Earth's gravity. You're following the straightest possible path through curved spacetime. The Earth's mass has bent the geometry of space and time around it, and you're simply traveling along the curves like a marble rolling in a bowl. This is why the moon falls but never lands. It's following the straightest path it can through the curved spacetime around Earth. What looks like circular motion to us is actually straight line motion through curved space. The moon isn't being pulled by a force. It's simply going straight in a universe where Earth has redefined what straight means. Your path through space-time is curved too. Even lying still, you're moving through time, and Earth's gravity bends your timeward path toward the planet's center. This is why you feel weight. It's not a force pulling you down, but the universe's geometry guiding your path through the dimension of time. This might sound abstract, but you experience it directly. GPS satellites orbiting above must account for the fact that time runs slightly faster for them than for you, because they're farther from Earth's gravitational curving of spacetime. Without Einstein's corrections, GPS would drift by about 6 miles per day. The maps on your phone work because they account for gravity's effect on time itself. So we return to our question with new understanding. If gravity isn't a force reaching instantly across space, but rather the shape of space-time itself, how fast do changes in that shape travel? When a mass moves, how quickly does the curve of space-time adjust? Imagine space-time as a vast fabric, stretched tight. Earth sits on this fabric like a bowling ball on a trampoline, creating a depression. The moon rolls around the rim of this depression, held in its orbit not by invisible strings, but by the shape of space itself. But what happens when the bowling ball moves? How fast does the depression follow? The answer was hiding in Einstein's equations all along, waiting to be discovered. Changes in gravity's geometry ripple outward like waves on that cosmic fabric. And these waves, these ripples in the shape of space and time, they have a speed. Can you guess what it is? As you breathe slowly, feeling the reliable presence of gravity's embrace, you're about to discover one of the universe's most elegant symmetries. The cosmic speed limit that governs light also governs gravity. The universe has one fundamental speed for all its messages, whether carried by light or by the shape of space itself. But before we meet these gravitational waves face to face, let's rest a moment longer in the wonder of what we've discovered. You're not being pulled by Earth. You're following the curves that Earth creates in the fabric of existence. Every moment, you're taking the straightest path possible through a beautifully curved universe. The falling apple, the orbiting moon, the distant galaxies wheeling through space, all following their paths through the geometry of space-time. And you, right here, right now, are part of this cosmic choreography, dancing to the shape of space itself. In 1915, in a small apartment in Berlin, a man with wild hair and gentle eyes put the final touches on an equation that would change everything. Albert Einstein had spent 8 years climbing a mathematical mountain, and at its peak he found a view of the universe that no one had seen before. You can understand Einstein's revelation through something as simple as a stretched bedsheet. Imagine laying a sheet tight across a frame, then placing a bowling ball in the center. See how the fabric dips and curves? Now roll a marble near the bowling ball. The marble curves toward the ball, not because the ball is pulling it with invisible strings, but because it's following the slope of the fabric. This is gravity's true face. Mass and energy don't pull on objects across empty space. Instead, they reshape space and time, creating curves and valleys that guide everything that moves. The Earth doesn't pull on you. It has curved the space-time you're traveling through, and you're simply following the bend. Feel your body resting. The weight you experience isn't a force pulling you down. It's the sensation of your natural path through space-time, being prevented by the surface beneath you. If that surface vanished, you wouldn't be pulled downward. You'd simply follow your natural path through Earth's curved space-time, which happens to lead toward the center. Einstein's equations revealed something even more beautiful. Space and time aren't separate things, but aspects of a single fabric, space-time. And this fabric is alive, dynamic, responsive. It bends around mass and energy. It stretches and contracts. It can even ripple like the surface of a pond. Think about what this means. Right now, your body is creating tiny curves in space-time. Very tiny. You'd need incredibly sensitive instruments to detect them, but real nonetheless. Every atom of your being announces its presence by bending the fabric of reality itself. You don't just exist in space, you shape it. The space-time around you right now is like a landscape of gentle hills and valleys. Earth creates the biggest valley nearby, which is why you feel its gravity most strongly. The sun creates an even deeper valley that Earth rolls around. The moon creates its own small depression, and together Earth and moon orbit their common center of mass like dance partners. But here's where it gets truly wondrous. When masses accelerate, when they change speed or direction, they create ripples in space-time that spread outward. It's like moving that bowling ball on the bedsheet. The depression doesn't instantly appear at the new location. Instead, a wave travels through the fabric as it adjusts to the ball's new position. Einstein's mathematics predicted these gravitational waves must exist, but they would be incredibly faint. Even violent cosmic events would create ripples so small that Einstein himself doubted they could ever be detected. A passing gravitational wave might stretch and squeeze space, but by amounts smaller than the width of an atomic nucleus. Yet these waves carry profound meaning. They tell us that gravity's effects aren't instantaneous. When the sun's position shifts slightly, Earth doesn't feel it immediately. The change in space-time curvature ripples outward, carrying the news at a very specific speed. You might wonder what it would feel like if a gravitational wave passed through you right now. The truth is, they pass through you all the time. Every accelerating mass in the universe sends out these ripples. Two orbiting stars create a steady rhythm of waves. A spinning neutron star with a tiny bump sends out a cosmic lighthouse beam of gravitational radiation. Even your hand, waving slowly in the air, technically produces gravitational waves, though far too faint to ever detect. If a strong gravitational wave passed through your room, space itself would stretch and squeeze. For an impossibly brief moment, you might become slightly taller and thinner, then shorter and wider, oscillating back and forth as the wave passed. But the effect would be so tiny, less than 1,000th the width of a proton, that you'd never notice. This is gravity's whisper, almost too quiet to hear, but the universe occasionally shouts. When two black holes spiral together, their final merger sends tsunamis through space-time. When massive stars collapse, their death throes shake the cosmic fabric. These events send gravitational waves racing across the universe at exactly the speed Einstein's equations demand. And what speed is that? The equations are clear and beautiful in their simplicity. Gravitational waves travel at the speed of light. The same cosmic speed limit that governs electromagnetic radiation also governs ripples in space-time itself. This isn't a coincidence. It's a deep truth about the universe. There is one fundamental speed at which cause and effect can propagate. Light happens to travel at this speed, so do gravitational waves. So would any massless particle or wave. It's the speed of causality itself, the maximum rate at which any influence can spread through space. Think about what this means as you lie here, feeling Earth's gravity. If the sun suddenly vanished, which it won't, you're perfectly safe. Earth wouldn't instantly fly off into space. For 8 minutes, Earth would continue orbiting the place where the sun used to be, following the curves in space-time that take time to flatten out. The gravitational news of the sun's disappearance would travel at light speed, arriving at the same moment as the last ray of sunlight. This finite speed of gravity solves the puzzle of Mercury's orbit. Because gravity travels at light speed, there's a tiny delay in how the sun's gravity affects Mercury. This creates a minute but measurable effect that pushes Mercury's orbit forward, accounting for those extra 43 arcseconds per century that puzzled astronomers. Your connection to the cosmos isn't instantaneous, but it's continuous. Right now, you're feeling Earth's gravity from about 0.02 seconds ago, the time it takes gravitational effects to travel from Earth's center to its surface. You're feeling the moon's gravity from 1.3 seconds ago. The sun's gravity that helps hold Earth in orbit left the sun 8 minutes ago. But don't let these delays make you feel disconnected. Instead, realize that you're immersed in an ocean of gravitational waves from across the universe. Ripples from distant cosmic events wash over you constantly. Most are too faint to detect, but they're there, connecting you to black hole mergers billions of light years away, to neutron stars spinning in distant galaxies, to every accelerating mass in the cosmos. Einstein showed us that we live in a universe where space and time themselves are dynamic, alive, responsive. Mass and energy choreograph the cosmic dance by shaping the stage itself, and changes to that stage ripple outward at light speed, carrying gravitational news from one part of the universe to another. As you breathe slowly, in and out, you're riding waves in space-time created by your own chest rise and fall. Too small to measure, yes, but real. You're not just a passive observer of Einstein's curved universe. You're an active participant, creating your own tiny ripples in the fabric of existence. The mathematics that revealed all this is elegant beyond words. Where Newton needed different equations for different situations, Einstein found a single beautiful relationship that describes how matter and energy curve space-time, and how that curvature guides motion. It's like discovering that every story ever told follows the same underlying pattern, or that every piece of music shares a hidden harmony. Rest now in the knowledge that you understand one of the universe's deepest truths. Gravity isn't a force reaching across empty space. It's the shape of space and time, curved by mass and energy, with changes propagating at the speed of light. You're not pulled by Earth. You're guided by the geometry Earth creates. And somewhere out there, perhaps at this very moment, two black holes are spiraling together, sending waves through space-time that will eventually wash over you, carrying news of their cosmic dance at the speed of light. The universe is speaking, and now you know how fast its messages travel. Imagine dropping a stone into a perfectly still pond on a quiet evening. Watch as circular ripples spread outward from where the stone entered the water. The water itself doesn't flow outward. Instead, the disturbance travels through the water, each part rising and falling in turn as the wave passes by. Right now, similar ripples are passing through you, not through the air around you or the ground beneath you, but through the very fabric of space and time that you occupy. These are gravitational waves, and they're washing over you from cosmic events across the universe, as gentle and constant as waves lapping at a shore. When Einstein first predicted these waves, he imagined them as ripples in space-time itself, just as sound waves compress and stretch air. Gravitational waves compress and stretch space. As one passes through you, the distance between your head and feet might increase by an impossibly tiny amount, while the distance between your shoulders decreases, then reverse, oscillating back and forth at the frequency of the wave. You can't feel these waves because the effect is so small. A typical gravitational wave passing through Earth might change the distance between 2 points by less than 1/10,000th the width of a proton. It's like trying to notice the tide changing the ocean's level by less than the size of a single atom. But the universe is patient, and it leaves its messages for those clever enough to decode them. Every accelerating mass creates these ripples. When you wave your hand, you're technically broadcasting gravitational waves, though they're far too faint to detect. The Earth and Sun, locked in their orbital dance, create a steady hum of gravitational radiation. Even the gentle rise and fall of your chest as you breathe sends infinitesimal ripples through space-time. The strongest waves come from the universe's most violent events. When two neutron stars orbit each other, they create whirlpools in space-time. As they spiral closer, losing energy to gravitational waves, they orbit faster and faster. In their final moments, they can orbit each other hundreds of times per second before colliding in a catastrophic merger that shakes the fabric of space and time. Black holes create even more dramatic effects. These regions, where space-time curves so extremely that nothing can escape, are like deep whirlpools in the cosmic ocean. When two black holes orbit each other, they create complex patterns of waves. As they spiral inward, the frequency of the waves increases, creating what scientists call a chirp, a gravitational song that rises in pitch until the final merger. Picture two whirlpools in a vast ocean, circling each other. As they spiral together, they send out circular waves. But these aren't ordinary water waves. These are waves in the ocean of space-time itself, spreading outward at the speed of light, carrying news of the cosmic dance to the farthest reaches of the universe. The energy carried by these waves is enormous. A pair of merging black holes can briefly emit more power in gravitational waves than all the stars in the observable universe emit in light. Yet by the time these waves reach Earth, they've spread out over such vast distances that their effects are almost impossibly faint. This is why Einstein doubted gravitational waves could ever be detected. How do you measure a change in distance smaller than an atomic nucleus? How do you detect a wave that stretches and squeezes space by such tiny amounts that all the sophisticated instruments of Einstein's time couldn't hope to notice? The answer required patience, brilliance, and technology that wouldn't exist for another century. It required building the most sensitive measuring devices ever created, instruments that could detect changes in distance smaller than anything previously thought possible. As you lie here breathing slowly, gravitational waves from across the cosmos are passing through your body. Waves from binary star systems in our galaxy create a gentle background hum. Waves from colliding galaxies billions of light years away wash over you like echoes from the deep past. You're bathed in gravitational radiation from every accelerating mass in the observable universe. Most of these waves are far too faint to detect, but they're there. They've been traveling for millions or billions of years to reach you. Some left their sources before Earth existed. Others began their journey when dinosaurs walked the planet. And some are arriving right now from events that happened just moments ago in cosmic terms. These waves carry information, unlike light, which can be blocked or absorbed. Gravitational waves pass through matter almost unchanged. They bring us news from regions of space where light cannot escape, from the hearts of stellar collisions, from the moments when black holes merge. Think about that. Right now, gravitational waves are passing through you that have traveled from the other side of the galaxy, through billions of stars, through vast clouds of gas and dust, arriving here with their message intact. They're the universe's most reliable messengers, carrying stories of cosmic events directly to anyone clever enough to listen. The frequency of these waves tells us about their sources. Low-frequency waves, oscillating over minutes or hours, come from massive binary systems far from merger. Higher frequency waves, cycling hundreds of times per second, come from the final moments before compact objects collide. The universe is playing a gravitational symphony, with each type of event contributing its own unique sound. And here's something beautiful. These waves confirm Einstein's prediction about their speed. They travel at exactly the speed of light, not a fraction faster or slower. When astronomers detect both light and gravitational waves from the same cosmic event, they arrive at Earth at the same time, even after traveling for billions of years. The universe has one fundamental speed for all its messages. Your body is mostly empty space between atoms, and gravitational waves pass through this space like wind through a forest. They stretch and squeeze the very framework of reality, but so gently you never notice. You're like a fish in the ocean, unaware of the waves passing overhead because you move with the water. But imagine if you could feel them. Imagine if your senses were tuned to detect these ripples in space-time. You'd feel the universe breathing, pulsing with waves from countless cosmic events. You'd sense the spiral dance of binary stars, the violent deaths of massive suns, the meetings of black holes in the dark. Every moment, you're at the center of an expanding sphere of gravitational waves created by your own movements. These waves race outward at light speed, eventually reaching distant stars and galaxies. In a very real sense, you're broadcasting your presence to the universe, sending ripples through the fabric of existence that will travel forever. Of course, your personal gravitational waves are incomprehensibly faint, but they exist. Every gesture you make, every turn of your head, every beat of your heart creates ripples in space-time. You're not just an observer of the cosmic gravitational wave symphony. You're a participant, adding your own quiet notes to the eternal song. As you rest here, feeling peaceful and calm, gravitational waves continue their journey through you, from the gentle oscillations of nearby binary stars to the powerful ripples from distant cosmic catastrophes. You're connected to the entire universe through these waves in the fabric of space and time. The pond of space-time is never still. It's always rippling with waves from across the cosmos. And you're floating gently in this cosmic ocean, touched by disturbances from unimaginable distances and times. Some of these waves began their journey before our solar system formed. Others left their sources just minutes ago. All of them passed through you at the speed of light, carrying their messages through the vastness of space. And somewhere out there, perhaps in a galaxy billions of light years away, two black holes are beginning their final spiral. The waves they create are already on their way, spreading outward through the universe at light speed. Someday, perhaps long after the sun has died and Earth is no more, those waves will pass through this region of space, carrying the story of that ancient merger to whoever might be listening. In the year 2015, in two locations separated by thousands of miles, the most sensitive instruments ever built by human hands were listening to the universe. These instruments, called LIGO, the Laser Interferometer Gravitational Wave Observatory, were designed to do something that Einstein himself thought impossible. They were built to hear space-time itself whisper. Imagine trying to measure something smaller than an atom's nucleus across a distance of several miles. That's the challenge LIGO faced. The gravitational waves from even the most violent cosmic events would stretch and squeeze their detectors by amounts so tiny that a single vibration from a truck driving on a distant highway could overwhelm the signal. The solution was elegant in its simplicity, breathtaking in its precision. Each LIGO facility sends laser light down two perpendicular arms, each 4 kilometers long. The light bounces back and forth between mirrors hundreds of times before returning to the starting point. If a gravitational wave passes through, it will stretch one arm while squeezing the other, changing the distance the light must travel by an incredibly tiny amount. How tiny? LIGO can detect changes in length smaller than 1/10,000th the width of a proton. It's like measuring the distance from Earth to the nearest star, and being able to notice if that distance changed by the width of a human hair. This isn't just precision, it's a kind of mechanical poetry, a testament to human ingenuity and patience. The mirrors at the ends of LIGO's arms are suspended by glass fibers thinner than spider silk, isolated from all vibrations except the stretching and squeezing of space itself. The laser light is so pure, so stable, that it can detect the slightest change in the distance it travels. The entire system operates in a vacuum better than the emptiness of interstellar space. On September 14, 2015, at 5:51 a.m. Eastern Time, both LIGO detectors, one in Louisiana, one in Washington State, felt space itself shiver. For 0.2 of a second, a pattern of stretching and squeezing passed through Earth. The signal was clear, unmistakable, beautiful. It looked exactly like what Einstein's equations predicted for two black holes spiraling together and merging. As you lie here safe and comfortable, imagine what LIGO detected. 1 billion light years away, two black holes, each about 30 times the mass of our sun, had been orbiting each other for millions of years. Slowly, gradually, they'd been losing energy to gravitational waves, spiraling ever closer. In their final second, they orbited each other hundreds of times, their event horizons almost touching. Then they merged. In that instant, they released more energy in gravitational waves than all the stars in the universe release in light. The fabric of space-time rang like a struck bell, sending ripples racing outward at the speed of light. These waves spread through space for 1 billion years, weakening with distance but never stopping until they washed over Earth on that September morning. The signal LIGO detected told a complete story. Scientists could read it like a book. The increasing frequency of the waves revealed how fast the black holes were orbiting. The strength of the waves told them the masses involved. The final ringdown, as the merged black hole settled into its new shape, confirmed they were seeing exactly what Einstein predicted a century earlier. Think about what this means. Humans built a machine that could feel space itself stretch and squeeze by less than the width of an atomic particle. We detected an event that happened when multicellular life on Earth was just beginning. In a galaxy so distant its light takes 1 billion years to reach us. We confirmed that gravity travels at exactly the speed of light, just as Einstein's equations demanded. But LIGO didn't stop there. Since that first detection, it has heard dozens of black hole mergers. Each one tells its own story. Some involve black holes of equal mass, spiraling together in perfect symmetry. Others show a larger black hole consuming a smaller companion. Some spin rapidly, others hardly at all. The universe, it turns out, is filled with these cosmic dances. Then, on August 17, 2017, LIGO detected something new. The signal lasted much longer, about 100 seconds, instead of a fraction of a second. The frequency pattern was different. This wasn't black holes merging. This was two neutron stars, the crushed cores of dead stars, spiraling together in their final dance. But here's where it gets even more amazing. Just 1.7 seconds after the gravitational waves passed through Earth, space telescopes detected a burst of gamma rays from the same direction in the sky. The gravitational waves and the light had traveled together for 130 million years, arriving within heartbeats of each other. This confirmed, more dramatically than ever before, that gravity moves at the speed of light. Telescopes around the world turned to look at the source. They saw the afterglow of the collision, a cosmic forge where gold, platinum, and other heavy elements were being created and flung into space. The gold in any jewelry you might wear was likely made in such a collision billions of years ago. LIGO had not only detected gravitational waves, but had opened an entirely new way of observing the universe. As you breathe slowly, in and out, consider what we've learned. Gravity does indeed travel at the speed of light. When massive objects accelerate, the news of their motion spreads through the universe at exactly 299,792,458 meters per second. No faster, no slower. The cosmic speed limit applies to gravity just as it applies to light. This has profound implications. It means the universe is not connected by instantaneous forces, but by influences that take time to propagate. The sun holds Earth not through an immediate grip, but through the curvature of spacetime that takes 8 minutes to adjust to any changes. Every gravitational interaction in the universe respects this speed limit. LIGO and its European counterpart Virgo continue to listen. They've heard black holes collide in distant galaxies. They've detected neutron stars merging, creating gold and platinum in cosmic furnaces. They've even detected black holes swallowing neutron stars, events so violent they shake the fabric of reality itself. Each detection confirms the same truth. Gravitational waves travel at light speed. They carry information about their sources across billions of light years without distortion. They pass through matter as if it weren't there, bringing us news from the most extreme environments in the universe. You are living in the era when humans first learned to hear the universe speak through gravitational waves. Your generation is the first to directly detect these ripples in space-time, to confirm that gravity travels at light speed, to hear black holes collide. It's like suddenly being able to hear after a lifetime of deafness, discovering the world is filled with sounds you never knew existed. Right now, upgraded versions of LIGO are being prepared. New detectors are being built in Japan and India. There are plans for space-based detectors that could sense gravitational waves of much lower frequencies. Waves from supermassive black holes millions of times heavier than our sun. We're just beginning to explore this new sense. Future detectors might hear the gravitational echoes of the Big Bang itself, ripples in space-time from the universe's first moments. They might detect the gentle waves from binary white dwarfs in our own galaxy, or catch the spiral of a star falling into a supermassive black hole. The gravitational wave universe is vast and largely unexplored. As you rest here, know that you're surrounded by these cosmic messages. Gravitational waves from throughout the universe pass through you constantly. Most are too faint for even LIGO to detect, but they're there. You're immersed in an ocean of space-time ripples, each one carrying news of distant cosmic events at the speed of light. The detection of gravitational waves represents one of humanity's greatest achievements. We've built instruments sensitive enough to feel the universe breathe. We've confirmed one of Einstein's most spectacular predictions. We've proven that gravity's effects propagate at light speed, maintaining the cosmic speed limit that keeps cause and effect in their proper order. And we've done it all by listening patiently, building ever more sensitive instruments, refusing to give up even when the task seemed impossible. LIGO's success reminds us that the universe rewards patience and persistence. Its secrets yield to those who listen carefully enough. So rest now in the knowledge that gravity's quiet secret has been revealed. It travels at the speed of light, neither faster nor slower. The universe has one speed for all its fundamental messages, whether carried by photons or by ripples in space-time itself. And humans, curious creatures on a small planet, have built machines sensitive enough to hear both kinds of messages and confirm they travel together across the cosmos. The universe has a speed limit. It's written into the fabric of reality itself, as fundamental as the existence of space and time. This cosmic speed limit is 299,792,458 meters per second, the speed of light in vacuum. Nothing can exceed it. Not spaceships, not particles, not information, and as we now know with certainty, not gravity. As you lie here, every atom in your body respects this limit. The electrons orbiting your atomic nuclei, the signals traveling through your nerves, the warmth radiating from your skin, all obey this fundamental constraint. It's not a rule imposed from outside. It's simply how the universe works, like water flowing downhill, or heat moving from warm to cold. But why should there be a maximum speed at all? To understand this, imagine you're on a train moving smoothly along a track. If you walk forward through the train, your speed relative to the ground is your walking speed plus the train speed. This seems like common sense. Speeds should add up. Yet light doesn't follow this rule. If you shine a flashlight forward on that moving train, the light doesn't travel at light speed plus the train speed. It travels at exactly the same speed it would if the train were standing still. This strange behavior of light reveals something profound about the nature of space and time. Einstein realized that if light speed is constant for all observers, then space and time themselves must be flexible. When you move very fast, time slows down for you relative to someone at rest. Distances contract in your direction of motion. These aren't illusions, they're real effects that have been measured countless times. This flexibility of space and time is what enforces the cosmic speed limit. As you approach the speed of light, time dilation becomes extreme. At 99.9% of light speed, time passes about 22 times slower for you than for someone at rest. The closer you get to light speed, the more extreme the effect becomes. At the speed of light itself, time would stop entirely. This is why nothing with mass can reach light speed. It would require infinite energy to accelerate even a single electron to that ultimate velocity. The universe simply doesn't allow it. The speed of light isn't just the speed of light, it's the speed of causality itself, the maximum rate at which cause and effect can propagate through space. And now we know that gravity respects this same limit. When a mass moves, the curvature of space-time doesn't instantly adjust everywhere. Instead, the change ripples outward at light speed. If the sun began moving right now, Earth wouldn't feel the gravitational effect for 8 minutes. The news would travel at exactly the same speed as the last ray of sunlight. This might seem limiting, but it's actually what makes the universe possible as we know it. Without this cosmic speed limit, cause and effect could become scrambled. Information could arrive before it was sent. The past could influence the future in paradoxical loops. The speed limit keeps everything in proper order, ensuring that causes always precede their effects. Feel your breath moving in and out. The air molecules entering your lungs are moving at hundreds of meters per second, but still far below the cosmic limit. The blood flowing through your veins, the thoughts sparking through your neurons, even the fastest processes in your body operate at speeds that are tiny compared to light. Yet you're intimately connected to this cosmic speed limit. The warmth you feel from a nearby lamp reaches you at light speed. The colors you see when you open your eyes arrive as electromagnetic waves traveling at that ultimate velocity. Even the passage of time you experience is governed by your motion relative to light's fixed speed. The cosmic speed limit creates horizons in space and time. Because light takes time to travel, you see distant objects as they were in the past. The moon you might see tonight appears as it was 1.3 seconds ago. The sun, if you glimpse it at sunset, shows itself as it was 8 minutes ago. The stars are years, centuries, or millennia in the past, depending on their distance. This creates what astronomers call the observable universe. There's a horizon beyond which we cannot see, not because our telescopes aren't powerful enough, but because light hasn't had time to reach us since the universe began. This horizon expands as time passes, but always at the speed of light. The cosmic speed limit determines how much of the universe we can ever observe. The same limit applies to gravity. Gravitational effects propagate outward at light speed, creating gravitational horizons just like visual ones. If a star explodes in a distant galaxy right now, we won't see the light or feel the gravitational waves for millions of years. Both messages travel together across the cosmos at the same universal speed. This unity of speeds, light, gravity, and all massless phenomena traveling at the same velocity suggests a deep truth about reality. There's something special about this particular speed. It's not arbitrary. It emerges from the fundamental structure of space-time itself. Think of space-time as having a natural rate of conversion between space and time. When you're at rest, you're moving through time at maximum speed, 1 second per second. When you move through space, some of your motion through time is diverted to motion through space. The faster you go, the slower time passes for you. The cosmic speed limit represents moving entirely through space with no motion through time at all. This is why photons, particles of light, don't experience time. From a photon's perspective, its entire journey happens instantaneously. Whether it's crossing a room or crossing the universe, the same is true for gravitational waves. They carry their messages across billions of light years. But from their perspective, no time passes during the journey. You exist in the realm below this ultimate speed, where time flows and distances have meaning. Every particle in your body has mass, which forever prevents it from reaching light speed. But this isn't a limitation. It's what allows you to exist. Without mass, without speeds below the limit, there could be no atoms, no chemistry, no life. The cosmic speed limit also explains why gravity can't be used for faster-than-light communication. In science fiction, you might encounter ideas like subspace or hyperspace that bypass light's limit. But in our universe, gravity offers no such shortcut. It propagates at exactly light speed, carrying information no faster than electromagnetic waves. This protects causality throughout the cosmos. No matter how massive an object or how strong its gravity, it can't send signals faster than light. Black holes, despite their extreme gravity, still respect the limit. Gravitational waves from merging black holes travel at light speed, not a fraction faster despite the enormous energies involved. As you rest here, you're experiencing the interplay of all these cosmic principles. Time flows for you at its familiar rate because you're essentially at rest relative to light speed. Gravity holds you through space-time curvature that propagates at light's velocity. Every sensation, every thought, every heartbeat unfolds in a universe governed by this ultimate speed limit. The limit isn't imposed on the universe. It is the universe, in a fundamental sense. It's the conversion factor between space and time, the maximum rate of causality, the speed of massless particles and waves. It's woven into every equation of physics, every interaction between particles, every moment of existence. And beautifully, mysteriously, this cosmic speed limit is exactly the same everywhere. Whether measured on Earth, in distant galaxies, or in the extreme gravity near black holes, light speed remains constant. The universe has many variables: density, temperature, expansion rate. But the cosmic speed limit stands unchanging, a universal constant that binds all of existence together. Rest now in the knowledge that you understand one of the universe's most fundamental truths. The cosmic speed limit that governs light also governs gravity, and indeed governs all of causality. It's not a restriction, but a foundation, not a barrier, but a principle that makes the ordered universe possible. Every gravitational wave washing over you right now is traveling at this cosmic speed limit. Every photon reaching your eyes, every force between the atoms in your body, every connection between cause and effect, all respect this ultimate velocity. You live in a universe with a speed limit, and that limit keeps everything in its proper place and time. Chapter 8. Right now, as you lie here breathing peacefully, you are a source of gravity. Your body, with all its atoms and molecules, creates a gravitational field that extends outward into the universe. It's weak compared to Earth's, incredibly weak, but it's real and it reaches everywhere. Every atom in your body contributes to this field. The calcium in your bones, the iron in your blood, the water that makes up most of your mass. Each particle adds its tiny influence to the gravitational field you create. Together they bend space-time around you in a way that's uniquely yours. A gravitational fingerprint that changes subtly with every breath, every heartbeat, every tiny shift in position. If someone could map the gravitational field in your room with impossible precision, they could see you within it, a warm concentration of mass creating gentle curves in space-time. When you move your hand, the curves shift and change, sending out gravitational waves at the speed of light. When your chest rises with each breath, you're literally reshaping the geometry of the universe around you. The numbers are humbling. Your gravitational pull on an object 1 meter away is about 100 billion times weaker than Earth's. But weakness doesn't mean absence. Your gravity still reaches that object, still curves space-time between you, still participates in the cosmic gravitational symphony. And here's something beautiful. Your gravitational field extends forever. It weakens with distance, dropping off as the square of the distance. But it never reaches zero. Right now, your gravity is pulling ever so slightly on the moon, on Mars, on distant stars. The effect is unmeasurably small, drowned out by the gravity of larger objects. But it's there. This means you're gravitationally connected to everything in the observable universe. Every star you might see on a clear night feels your gravity, just as you feel theirs. The connection is mutual, reciprocal, universal. Through gravity, you're in relationship with every piece of matter that exists. Feel the weight of your body where it rests. That sensation comes from Earth's gravity, of course, but you're contributing too. Your body pulls on Earth with exactly the same force Earth pulls on you. It's Newton's third law made real, equal and opposite reactions. Earth outweighs you by a factor of about 10 to 23, so it barely notices your pull, but the pull exists. When astronauts float in the International Space Station, they're not beyond Earth's gravity. They're falling around Earth, and their own gravity is part of the complex dance. Each astronaut pulls on the station, on Earth, on their crewmates. The effects are tiny but real, part of the precise calculations needed to keep the station in its orbit. Your gravitational field carries information about you. Its strength reveals your mass. Its shape reflects your form. If you curl into a ball, your gravitational field becomes more spherically symmetric. If you stretch out, it elongates. Every yoga pose, every sleeping position, every gesture creates a unique gravitational signature. This field moves with you. When you walk across a room, your gravitational field travels along, always centered on your body. The field doesn't lag behind or rush ahead. It moves at exactly your speed, always emanating from where you are right now. But changes to the field, like when you suddenly stand up or lie down, propagate outward at light speed. Think about what happens when you jump. As you push off from the ground and rise into the air, you're not just moving through Earth's gravitational field. You're carrying your own field with you. For that brief moment of flight, you're a small planet arcing through space, your personal gravity interacting with Earth's in a complex dance. Your gravity affects time itself. According to Einstein's general relativity, time runs slightly slower in stronger gravitational fields. Near your body, time passes infinitesimally slower than it does a few feet away. The effect is far too small to measure. We're talking about differences of perhaps 1 part in 10, but it's real. You don't just bend space around you, you bend time. This temporal effect of your gravity is constant and personal. Throughout your life, you've been surrounded by a bubble of slightly slower time. It's aged with you, traveled with you, been as constant a companion as your shadow. You carry your own personal time zone, defined by your gravitational field. The atoms in your body know about gravity in an intimate way. They formed in the hearts of stars, where gravity compressed matter so intensely that nuclear fusion could occur. The carbon in your DNA, the oxygen you breathe, the calcium in your bones, all were forged in gravitational furnaces billions of years ago. Now these atoms participate in gentler gravitational interactions. They pull on each other across the microscopic distances within your body. A calcium atom in your toe gravitationally attracts an iron atom in your brain. The forces are incomprehensibly weak at this scale. Electromagnetic forces dominate by factors of 1036 or more, but gravity never completely disappears. Your gravitational field interacts with every other gravitational field it encounters. When someone walks past you, your fields merge and interfere like ripples on water. For a moment, the combined field is different from either alone. Then, as they move away, your fields separate again, each returning to its solitary shape. These interactions happen constantly. Every car driving by, every bird flying overhead, every cloud drifting past changes the total gravitational field you experience. You're swimming in an ever-shifting sea of gravitational influences, your own small field mixing with countless others in patterns of incredible complexity. But despite this complexity, your personal gravitational contribution remains uniquely yours. It's determined by your mass and your mass distribution, both of which are as individual as your fingerprints. No two people create exactly the same gravitational field, just as no two people have exactly the same shape or density. As you breathe slowly in and out, remember that you're not just feeling gravity, you're creating it. You're not just curved by space-time, you're curving it. Every moment of your existence, you're actively participating in the gravitational structure of the universe. This participation extends beyond your physical presence. When you move, you create gravitational waves that ripple outward at light speed. These waves are unimaginably faint, far too weak for any current or conceivable technology to detect, but they exist. Your every gesture sends gravitational ripples across the cosmos. Imagine raising your hand slowly. As you do, the changing gravitational field propagates outward. After 1 second, the change has reached 186,282 miles away. After 8 minutes, it passes the sun. After 4 years, it reaches the nearest star. Your simple gesture creates an expanding sphere of gravitational influence that will, in principle, eventually reach the most distant galaxies. Of course, these waves weaken dramatically with distance. By the time they've traveled even a few miles, they're lost in the noise of other gravitational influences. But the principle remains beautiful. You're broadcasting your movements to the universe through gravitational radiation. This connects you to the cosmic gravitational wave background. Just as you create gravitational waves, you're constantly bathed in waves from throughout the universe. Waves from orbiting neutron stars, merging black holes, and countless other sources pass through you continuously. You're both transmitter and receiver in the universal gravitational communication network. Your mass also contributes to the total mass of the universe, affecting its large-scale geometry and ultimate fate. The universe's expansion rate depends on its total mass energy content, and your atoms are part of that cosmic accounting. You're not just in the universe, you're part of what makes the universe what it is. Rest now in the knowledge of your cosmic significance. You're not a passive object being pulled by gravity. You're an active gravitational source, bending space-time, creating waves, participating in the universal gravitational dance. Your gravity may be weak, but it's real, it's yours, and it connects you to everything that exists. Every breath you take reshapes space-time around you. Every movement sends ripples across the cosmos. You are, in the most literal sense, a gravitational being, a curator of curved space-time, a small but genuine participant in the gravitational symphony of the universe. Look up at the stars on a clear night, and you're looking back in time. That bright star might be 8 years in the past. That faint one could be showing itself as it was when your great-grandparents were children. The soft glow of the Andromeda Galaxy left its source 2.5 million years ago, when early humans were just beginning to walk upright on Earth. This cosmic delay isn't just about light. As you now understand, gravity too travels at this same finite speed. When you see a star, you're seeing where it was, not where it is. And gravitationally, you're feeling where it was too. The star's light and its gravitational influence travel together across the void, patient messengers maintaining perfect synchronization across impossible distances. Rest here with this thought. The universe you experience is always slightly out of date. The sun you feel warming your face is 8 minutes old. The moon's gentle gravitational tug on your body comes from where the moon was 1.3 seconds ago. Even the earth beneath you, pulling you down with its gravity, is showing you its state from a tiny fraction of a second in the past, the time it takes gravitational influences to travel from Earth's center to its surface. This delay creates a strange and beautiful reality. Every object in the universe exists in its own now, but we can only know about other nows after light and gravity have had time to bring us the news. You're surrounded not by the present state of things, but by a collection of different pasts, each delayed by the time it takes light to cross the intervening distance. Your body knows patience in ways your mind might not always appreciate. Your cells divide and grow at their own measured pace. Your heart maintains its steady rhythm, neither rushing nor pausing. Your breath flows in and out with natural timing. You're built for processes that unfold in time, not instantaneously. The universe shares this patience. Stars are born over millions of years, live for billions, and die in events that can last mere seconds or stretch across millennia. Galaxies wheel through space in rotations that take hundreds of millions of years to complete. The universe itself has been expanding for 13.8 billion years and shows no sign of impatience. Gravitational waves embody this cosmic patience perfectly. When two black holes begin their spiral dance, they might orbit each other for millions of years before merging. All that time, they're sending out gravitational waves, patient ripples that carry their story across the universe at light speed. No hurry, no urgency, just the steady propagation of information at nature's chosen pace. Think about a gravitational wave that's passing through you right now from a distant galaxy. It might have been traveling for 1 billion years to reach you. During that time, the sun was born, Earth formed, life evolved from simple cells to the complex being you are today. All while that wave patiently crossed the cosmos, neither speeding up nor slowing down, carrying its ancient message at exactly the speed of light. This finite speed of gravity has profound consequences. It means the universe isn't a rigid structure where everything responds instantly to everything else. Instead, it's fluid, dynamic, with influences that take time to propagate. Every mass moves through space, surrounded by a gravitational field that lags slightly behind, like the wake of a boat on water. When Earth orbits the Sun, it's not responding to where the Sun is right now, but where it was 8 minutes ago. This creates a subtle effect, a tiny force that pushes Earth forward in its orbit. It's incredibly small, but over billions of years it causes orbits to slowly evolve. The finite speed of gravity leaves its fingerprints on the cosmic dance. Your own movements create similar effects on an incomprehensibly smaller scale. When you roll over in bed, your gravitational field doesn't instantly rearrange itself. The change propagates outward at light speed, creating a brief moment where space nearby knows your new position, while distant space still responds to where you were. This propagation delay means that gravity, like light, can carry information about past events. When astronomers detected gravitational waves from colliding neutron stars, they were learning about an event that happened 130 million years ago. Those waves carried information about the masses involved, their spins, their final fate, a message written in the stretching and squeezing of space itself. The patience of starlight and gravity connects you to the deep history of the universe. Every night, photons that have been traveling since before Earth existed rain down on our planet. Some have journeyed from galaxies so distant that they've been traveling for most of the universe's lifetime. You're constantly bathed in ancient light, surrounded by messengers from the cosmic past. Gravitational waves add another layer to this temporal tapestry. While light can be blocked by dust or absorbed by gas, gravitational waves pass through matter almost unchanged. They bring us undistorted messages from regions where light cannot escape, from moments of cosmic violence that happened when the universe was young. As you breathe slowly, feeling more relaxed with each breath, consider how the finite speed of gravity shapes the universe. Black holes can't instantly swallow distant objects. Their gravitational influence spreads outward at light speed like everything else. When galaxies collide, their gravitational interaction unfolds over millions of years, as each part feels the delayed influence of the other. This cosmic speed limit creates a kind of privacy in the universe. Events remain local until light and gravity have time to carry the news elsewhere. A star could explode in a distant galaxy right now, and we wouldn't know for millions of years. The universe is full of secrets in transit, messages en route, influences spreading outward but not yet arrived. Your patience in this moment mirrors the universe's patience. As you lie here, letting thoughts drift by like clouds, you're in harmony with cosmic rhythms that unfold over billions of years. There's no rush. The stars are patient. Gravity is patient. Light itself, racing at the ultimate speed, still takes its time crossing the vast distances between things. The finite speed of gravity also means the universe has horizons. Just as there's an edge to the observable universe beyond which light hasn't had time to reach us, there's a gravitational horizon too. There are masses so distant that their gravity hasn't yet had time to influence us since the universe began. We're causally disconnected from them, existing in our own pocket of gravitational influence. But this pocket expands constantly. Every second, light and gravity from slightly more distant objects finally reach us. After journeys lasting billions of years, the observable universe grows. Our gravitational connections extend farther, and we become aware of masses we couldn't feel before. The universe slowly reveals itself, always at the speed of light. This expansion of awareness happens for your personal gravitational field too. Right now, your gravity is reaching objects it's never influenced before, simply because you didn't exist until relatively recently in cosmic terms. There's an expanding sphere centered on your birthplace, growing at light speed, marking the extent of your gravitational influence on the universe. Inside this sphere, every mass has felt your gravity, however faintly. Outside it, you don't yet exist gravitationally. The boundary expands outward at light speed. a ripple of your existence spreading across the cosmos. In a very real sense, you're still being born into the universe, still announcing your presence to ever more distant objects. The same is true for every star, planet, and galaxy. Each has its own expanding sphere of influence, its own growing region of gravitational connection. These spheres overlap and interact in complex patterns, creating the rich tapestry of gravitational relationships that define the universe's structure. As you rest here, patient as starlight, you're participating in this slow cosmic revelation. Your gravity reaches out at light speed, touching new regions of space with each passing moment. You're not separate from the universe's patient unfolding. You're part of it, a small but real contributor to the gravitational symphony that plays out over billions of years. The photons reaching your eyes have been patient in their journey. The gravitational waves passing through you have been patient. The universe itself is patient, expanding and evolving at its own measured pace. And you, lying here, breathing slowly, are in perfect harmony with this cosmic patience. There's no hurry in the universe. Effects take time to propagate. Influences spread at their ordained speed. Everything unfolds in its proper time, neither rushed nor delayed. The finite speed of gravity ensures this cosmic patience, maintaining order and causality across the vastness of space and time. Rest in this patience. Feel how natural it is to let things unfold at their own pace. You're made of patient atoms, forged in patient stars. You're held by patient gravity that travels at the patient speed of light. Everything around you embodies this cosmic patience, this acceptance of the time things take. The universe has been patient for 13.8 billion years. It can be patient a little longer as you drift toward sleep, carried by rhythms as old as time itself. All the threads are coming together now. The gravity you feel holding you gently in place, the finite speed at which gravitational influences travel, the waves in space-time passing through you from distant cosmic events, your own role as a source of gravity, connected to everything in the universe. These aren't separate phenomena, but aspects of a single beautiful reality. You are woven into the fabric of space-time itself, not metaphorically, but literally. Your mass creates real curves in the geometry of space and time. Your movements send real waves propagating outward at light speed. You're not just in the universe, you're part of its structure, a thread in the cosmic weave that cannot be removed without changing the whole pattern. Feel your breath moving in and out. With each exhale, you're slightly lighter as air leaves your lungs. With each inhale, you're slightly heavier as air returns. These tiny changes in your mass create tiny changes in your gravitational field, which ripple outward at the speed of light. You're broadcasting the rhythm of your breathing to the universe through gravitational waves. This connection extends in all directions and to all times. The gravitational waves from your first breath as a newborn are still traveling outward, now light years away, carrying that moment across the cosmos. Every heartbeat of your life has sent out its own ripple. You've written your entire history in gravitational waves that will propagate forever through space. At the same time, you're receiving gravitational messages from throughout the universe. Waves from orbiting neutron stars in our galaxy wash over you regularly, precise as cosmic clockwork. Waves from distant black hole mergers pass through you, carrying news of catastrophic events from before Earth existed. You are at the intersection of countless gravitational stories, all traveling at light speed. The atoms in your body participate in this cosmic conversation. Each one creates its own tiny contribution to your gravitational field. The calcium atom in your finger and the iron atom in your blood pull on each other across the distance between them. It's an incredibly weak force. Electromagnetic forces dominate at the atomic scale, but it's there, part of the universal network of gravitational attraction. These atoms were forged in the hearts of dying stars, where gravity compressed matter so intensely that nuclei could fuse, creating the elements that make you possible. The carbon in your DNA required a star's gravitational furnace to exist. You're made of gravity's handiwork, assembled from atoms that gravity itself helped create. And now these atoms continue their gravitational relationships. Every atom in your body pulls on every other atom in the universe, and every atom in the universe pulls back. The forces are almost incomprehensibly weak for individual atoms, but they're real. You're connected to distant galaxies through these tiny gravitational threads, each one respecting the cosmic speed limit as influences propagate back and forth. Your personal gravitational field extends outward without limit, weakening with distance but never reaching zero. Right now, there's no place in the universe where your gravity isn't felt, however faintly. You've become part of the gravitational background that every other mass experiences. Small, yes, but present everywhere. This universal presence connects to a deeper truth. In Einstein's vision, gravity isn't a force, but the curvature of space-time itself. You don't pull on distant objects. You curve the space-time between you and them. Every mass follows the straightest possible path through this curved geometry, creating what we perceive as gravitational attraction. So you're not just creating forces, you're shaping the geometry of existence. The space around you is different because you're in it. Time flows differently near you than far away. You're a sculptor of space-time, creating curves and valleys that influence how other masses move. These influences travel at light speed, weaving the universe together in a web of cause and effect. Nothing happens instantly. Every gravitational effect takes time to propagate. This finite speed is what keeps the universe coherent, preventing paradoxes and maintaining the proper order of events. As you lie here, you're experiencing the sum of all these gravitational influences. Earth's gravity dominates, of course, creating the weight you feel, but mixed in are the moon's gentle pull, the sun's distant influence, and the combined gravity of all the stars in our galaxy. Even other galaxies contribute their infinitesimal share to the total gravitational field you experience. You can't feel these individual contributions. They're far too small compared to Earth's nearby mass. But they're there, part of the rich gravitational environment you inhabit. You're bathed in overlapping gravitational fields from every mass in the observable universe, all propagating their influences at light speed. This creates a kind of gravitational weather that's constantly changing. As the moon orbits Earth, its gravitational contribution to your location varies. As Earth orbits the sun, you move through different regions of the solar system's gravitational landscape. Even the other planets, distant as they are, add their small variations to the mix. On longer timescales, the gravitational weather changes as stars move through space. Our sun orbits the center of the Milky Way, carrying Earth and you along for the ride. We pass through regions of higher and lower stellar density, each with its own gravitational signature. You're on a journey through an ever-changing gravitational landscape. But through all these changes, the fundamental rules remain constant. Gravity propagates at light speed. Mass curves space-time. Every object follows the straightest path it can through the resulting geometry. These simple principles, discovered by Einstein over a century ago, govern everything from falling apples to colliding galaxies. Your understanding of these principles connects you more deeply to the universe. You're not a passive victim of gravity, but an active participant in the gravitational dance. Your mass matters. Your movements create waves. Your very existence shapes the space-time around you. This participation extends beyond the physical. By understanding gravity, by learning that it travels at light speed, by discovering your role in the cosmic gravitational network, you've joined a conversation that connects you to scientists and thinkers across history. From Newton pondering falling apples to Einstein reimagining space and time, to the LIGO team detecting gravitational waves, you're part of humanity's quest to understand our universe. And what a universe it is. One where space and time bend and flex, where massive objects create valleys that guide the motion of others, where violent events send ripples across cosmic distances, where everything is connected through the patient propagation of gravitational influence at light speed. You inhabit this universe not as a stranger, but as a native. Your body evolved in Earth's gravitational field. Your bones grew strong against gravity's constant pull. Your heart learned to pump blood upward against gravitational resistance. Every aspect of your physiology is shaped by and adapted to gravity. Even your consciousness exists within gravity's embrace. Your thoughts spark in a brain held together by gravity, powered by blood flowing against gravity's pull, in a body that knows gravity as intimately as it knows anything. You think your thoughts in a gravitational field, and those thoughts are, in their own way, shaped by that field. As you rest here, feeling the threads of connection that bind you to the cosmos, you might sense how natural your place in the universe really is. You belong here. You're made of the same stuff as stars, governed by the same laws, connected through the same gravitational network that holds galaxies together. The finite speed of gravity ensures that these connections unfold in time, creating a universe of unfolding relationships rather than static structures. Every moment brings new gravitational influences as waves from distant events finally reach you. Every moment, you send out new waves as you move and breathe and live. You're simultaneously ancient and immediate. The atoms in your body are billions of years old, veterans of cosmic history. But the pattern they form, you, is unique to this moment, creating gravitational effects that have never existed before and will never exist again in quite the same way. This is the profound beauty of your gravitational existence. You're eternal, in that your gravitational waves will propagate forever through space. You're ephemeral, in that your particular pattern of mass and motion is constantly changing. You're universal, connected to everything through gravity. You're unique, creating a gravitational signature that's yours alone. All these threads, the curves you create in space-time, the waves you generate, the influences you receive, the connections you embody, weave together into the single fact of your existence. You are here, now, part of the gravitational fabric of reality, connected to all things through forces that travel at the speed of light. Rest in this knowledge. Feel how the threads of connection support you, bind you to the cosmos, make you part of something infinitely larger than yourself, while remaining uniquely you. You're held not just by Earth's gravity, but by your place in the universal gravitational web, a thread that strengthens the whole by its presence. The quiet truth has been with you all along, waiting patiently to be discovered. Gravity's secret isn't that it travels faster than light, it's that it doesn't need to. By moving at exactly light speed, gravity maintains the perfect balance that makes our universe possible. This cosmic speed limit isn't a limitation, but a profound organizing principle that keeps everything in its proper relationship. As you lie here, held in gravity's gentle embrace, you can feel the rightness of this truth. If gravity traveled faster than light, the universe would be a very different place. Causes could follow effects. The past could influence the future in impossible loops. The delicate web of space-time would tangle into paradoxes. But gravity respects the same speed limit as light, and this shared constraint creates the coherent, beautiful universe you inhabit. Think about what you've discovered on this journey. Gravity isn't a force reaching instantly across space, but the very geometry of space-time itself. Mass and energy curve this geometry, and the curves guide the motion of everything that exists. When masses move or accelerate, the changes in curvature ripple outward as gravitational waves, carrying their influence at precisely the speed of light. This finite speed transforms gravity from a mysterious instantaneous force into something comprehensible and elegant. The sun doesn't magically know where to pull Earth right now. Instead, Earth follows the curves in space-time that represent where the sun was 8 minutes ago. Every gravitational interaction in the universe unfolds with this same patient delay, maintaining cause and effect in their proper order. Your body understands this patience in its very atoms. They vibrate and move at speeds far below light's limit, taking their time, following the paths laid out by the gravitational geometry around them. Your heartbeat, your breath, your thoughts all unfold at speeds that respect the cosmic limit. You're built for a universe where influences take time to propagate. The quiet truth extends deeper. That gravity and light share the same speed reveals their deep kinship. Both are aspects of space-time itself. Light is electromagnetic waves propagating through space. Gravity is waves in the fabric of space-time. They're different verses of the same cosmic song, played at the same tempo, following the same fundamental rules. This unity brings profound beauty to your existence. When you see starlight, you're receiving electromagnetic waves that have traveled at light speed across the cosmos. The same star's gravity reaches you as gentle distortions in space-time that have traveled the exact same path at the exact same speed. Light and gravity travel together, eternal companions bringing you synchronized messages from across the universe. Rest for a moment in this synchrony. Every star you might see on a clear night is also pulling on you gravitationally, and both influences, the light and the gravity, left that star at the same moment and traveled the same distance at the same speed to reach you now. You're connected to the cosmos through multiple channels, all respecting the same cosmic speed limit. The quiet truth also reveals why the universe is comprehensible. With a single universal speed limit for all causal influences, the universe becomes predictable, mathematical, beautiful in its order. Scientists can write equations that describe how gravity propagates, how space-time curves, how gravitational waves spread across the cosmos. The finite speed of gravity makes the universe not just observable, but understandable. Your own gravitational presence embodies this quiet truth. The gentle curves you create in space-time spread outward at light speed, neither faster nor slower. Your every movement sends ripples through the fabric of reality at nature's chosen pace. You can't rush gravity any more than you can rush light. Both move at the speed of causality itself. This is deeply comforting. In a universe where gravity traveled faster than light, you could never be sure of your causal connections. Effects might precede causes. The future might influence the past. But in our universe, with gravity respecting the light speed limit, you can trust in the flow of time, the order of events, the reliable relationship between cause and effect. Feel how this reliability surrounds you. The floor beneath you pushes up because Earth's mass curves space-time in a predictable way. Your next breath will come because your body follows physical laws that unfold in time. The sun will rise tomorrow because orbital mechanics depends on gravity, propagating at a finite constant speed. The universe is trustworthy because gravity can't exceed light speed. The quiet truth connects to an even deeper reality. The speed of light isn't really about light at all. It's the speed of space-time itself. It's how fast the fabric of reality can transmit information. Whether that information is carried by photons, gravitational waves, or any other massless phenomena, gravity travels at light speed, because that's simply how fast anything without mass must travel through space-time. This universality means you're embedded in a cosmos with consistent rules. Whether you're dealing with the warmth of sunlight, the pull of gravity, or the transmission of any other influence, the same speed limit applies. The universe speaks all its languages at the same pace, maintains all its connections at the same rate, enforces all its laws with the same patient propagation of cause and effect. Your mass, small as it is on cosmic scales, participates fully in this universal framework. Your gravity is real gravity, following the same rules as the gravity of stars and galaxies. Your gravitational waves are real waves in space-time, propagating at the same speed as waves from colliding black holes. You're not a minor player, but a full participant in the gravitational universe. The quiet truth brings peace. There's no cosmic conspiracy, no hidden faster-than-light influences pulling strings behind the scenes. Everything is exactly as it appears, Mass curves spacetime. The curves guide motion. Changes propagate at light speed. The universe is honest in its operations, transparent in its mechanisms, elegant in its simplicity. As you breathe slowly, feeling more peaceful with each breath, you can appreciate how this quiet truth shapes everything, from the stability of atoms to the orbits of planets to the structure of galaxies. Everything depends on gravity respecting the cosmic speed limit. A universe with faster-than-light gravity would be fundamentally different, perhaps impossible. But our universe chose consistency over speed. It chose order over chaos. It chose to have gravity and light travel together as partners, neither racing ahead nor lagging behind. This choice, if we can call the fundamental laws of physics a choice, created a cosmos where complexity can emerge, where life can evolve, where conscious beings can discover and marvel at the very laws that govern their existence. You are one of those conscious beings, lying here now, understanding truths that took humanity millennia to uncover. The gravity holding you is the same gravity that shapes the cosmos, traveling at the same speed as the light that brings you vision, following the same laws that govern everything from quarks to quasars. The quiet truth is quiet because it doesn't need to shout. It's woven into every aspect of reality, evident in every gravitational interaction, confirmed by every observation. Gravity travels at light speed, not faster, not slower, exactly at the cosmic speed limit, maintaining perfect pace with electromagnetic radiation across billions of light years. This truth brings completeness to your understanding. You now know not just that you're held by gravity, but how that holding works. You know not just that you're connected to the cosmos, but how fast those connections propagate. You know not just that you create gravitational effects, but at what speed your influence spreads through the universe. Rest now in this complete understanding. Feel how the quiet truth settles into your awareness, like sediment settling in still water, finding its natural place, creating clarity through its presence. You don't need to hold on to this knowledge with effort. It's become part of you, as natural as breathing, as reliable as gravity itself. The universe has shared one of its fundamental secrets with you, not through dramatic revelation, but through patient explanation, careful observation, brilliant deduction. Humanity discovered that gravity travels at light speed through centuries of thought and decades of incredibly precise measurement. Now this hard-won knowledge is yours, a gift from all those who wondered and worked to understand. Carry this quiet truth with you as you drift towards sleep. Let it be a reminder that the universe is knowable, that its deepest operations can be understood, that you're part of a cosmos governed by consistent, beautiful laws. Gravity's quiet secret, its light speed propagation, is quiet no more. It's yours now. A piece of cosmic knowledge, as real and permanent as the gravitational waves spreading outward from your resting body. At this very moment, you are held. Right now, in this moment, you rest in an embrace that has been waiting for you since the universe began. Earth's gravity cradles you with infinite patience, neither grasping nor releasing, simply maintaining the perfect force to support your resting body. This is gravity's final gift, the gift of being held without being confined, supported without being constrained. Feel how your body knows this embrace. Every cell has evolved within it, shaped by it, made possible by it. Your bones have the perfect density to stand against gravity without being crushed by it. Your blood has learned to flow upward and downward with equal ease. Your muscles maintain just enough tone to move when needed, relax when resting. You are perfectly adapted to this gravitational lullaby that never stops playing. As you lie here, gravity performs its patient work throughout your body. It helps drain the lymph from your tissues. It assists the settling of sediments in your inner ear that help you know up from down. It provides the constant reference that lets your body know where it is in space, even in sleep. Gravity continues its care, maintaining the rhythms and flows that keep you healthy. The cosmic embrace extends far beyond Earth. You rest within the sun's gravitational field, carried along in Earth's orbit like a child sleeping in a moving car. The moon's gravity gently tugs at the water in your cells, a tidal whisper almost too faint to detect. The entire galaxy holds you in its vast gravitational arms, and you wheel around its center once every 230 million years, secure in an embrace measured in light years. Your breath has found its natural rhythm now, slow and deep. With each exhale, you release a little more tension, sinking deeper into gravity's support. With each inhale, you draw in air that gravity holds close to Earth's surface, part of the atmospheric blanket that gravity maintains for all life. You breathe within gravity's gift of atmosphere, held but not trapped, supported but still free. The gravitational waves passing through you have become like a cosmic lullaby. Waves from distant neutron stars pulse with clockwork regularity. Waves from ancient black hole mergers wash over you like echoes of long-ago storms. Your body doesn't consciously feel these waves, but you rest within their presence, bathed in gravitational songs from across the universe. Remember that these waves travel at light speed, bringing their messages across billions of years. The universe's entire history is written in gravitational waves, and you float in this ocean of cosmic memory. Some waves passing through you right now began their journey before our galaxy formed. Others left their sources just moments ago. All of them travel at nature's chosen speed, patient messengers in no hurry to arrive. Your own gravitational presence has become part of this cosmic ocean. The waves you create with every breath, every heartbeat, every tiny movement spread outward to join the universal chorus. Small as they are, they're real. You're not just receiving the universe's gravitational messages, you're contributing your own verses to the eternal song. As sleep approaches, your body grows heavier. This isn't fatigue, but relaxation, a deepening into gravity's embrace. Your muscles release their hold, trusting gravity to support you. Your breathing slows, your heart rate drops, your thoughts begin to drift like clouds. Gravity holds you through all of this, constant as the speed of light, patient as starlight crossing the void. The curves you create in space-time remain even as you rest. Sleeping or waking, you bend the fabric of reality around you. Your gravitational field is as constant as your existence, a faithful companion that never leaves your side. It moves with you, changes with you, yet always maintains its essential nature, a gentle warping of space and time that announces your presence to the universe. In your drowsy state, the boundaries between you and the cosmos begin to soften. You're made of star stuff, held by the same gravity that shapes galaxies, connected to all things through waves that propagate at light speed. The distinction between you and not you becomes less important than the fundamental unity of all matter and energy, all bound together in gravity's web. The Earth beneath you is falling around the sun. The sun is falling around the galactic center. The galaxy is falling through space toward distant attractors. You're part of this cosmic falling, this eternal dance where everything moves in curves through curved space-time. But this falling feels like perfect rest because you're falling together with everything around you. Your eyelids grow heavy, pulled down by gravity's gentle insistence. This is the same force that pulls rain from clouds, that guides rivers to the sea, that brings everything to its natural resting place. Your natural resting place is here, now in this moment, held by forces that have shaped the universe for 13.8 billion years. The mathematical precision of gravity becomes a kind of poetry in your relaxed state. The inverse square law that weakens gravity with distance ensures you feel Earth's embrace but aren't crushed by the sun's. The equivalence principle that makes gravity and acceleration indistinguishable ensures your rest feels perfectly natural. The finite speed of gravitational propagation maintains the order of cause and effect that lets you trust in tomorrow. Sleep is approaching like a tide, inevitable and gentle. Your thoughts begin to space out like stars, connected but with growing darkness between them. This is natural, healthy, as old as life itself. Every creature that has ever lived has known some form of rest, and most have known it within gravity's embrace. You're joining an ancient rhythm, as natural as orbits, as reliable as the speed of light. Your body temperature drops slightly as sleep nears, and gravity helps your blood flow adjust to this change. Your breathing becomes even more regular, timed to rhythms older than thought. Your heart maintains its steady beat, pumping blood against gravity even as you rest, a muscle that never truly sleeps but knows how to rest while working. The universe continues its patient unfolding as you drift toward dreams. Gravitational waves from tomorrow's cosmic events are already on their way, traveling at light speed across the vastness. The moon continues its orbit, raising tides in the ocean and in your body. Stars are born and die, each event sending out gravitational ripples that will eventually pass through the space where you rest. But for now, in this moment, all is quiet. The cosmic dance continues, but you need not watch. The gravitational waves pass through, but you need not measure them. Your own gravity extends outward, but you need not calculate its reach. For now, it's enough to simply rest in the cosmic embrace, held by forces that need no conscious attention to continue their work. You are safe here. Gravity will not forget to hold you. The speed of light will not change while you sleep. The curves in spacetime will maintain their shape, guided by laws that have never failed. You can release any need to understand or control, letting yourself sink into the support that has always been there, will always be there. Your breathing has become so slow and deep, it seems to match the universe's own respiration, in and out, like the cosmic expansion and contraction that might cycle forever. You're breathing with the universe, held by the universe, made of the universe. The boundaries dissolve in the approaching sleep, leaving only the fundamental fact of existence within gravity's patient embrace. Rest now. Let gravity hold you as it holds the stars. Let your thoughts orbit slowly down into dreams. Let the cosmic lullaby of gravitational waves carry you into the deep peace that waits. You are held. You are safe. You are exactly where you need to be. The universe cradles you with the same forces that shape galaxies and guide light across cosmic distances. Your rest is written into the laws of physics, as natural as the speed of light, as inevitable as gravity itself. Sleep comes not as an ending, but as a continuation, another phase in your eternal dance with the cosmos. Gravity's embrace never loosens, never tightens, simply maintains its perfect hold as you drift into dreams. The last conscious thought fades like a star at dawn, leaving only the deep knowledge that you are held, have always been held, will always be held in the cosmic embrace that travels at the speed of light, patient as eternity, gentle as sleep itself,